Okay, hello, my name is Suresh Nair Baskaran and I am from Group J4CEM1101A, and today I will be discussing and explaining a bit about our calculus assignment, which involves maximum and minimum problem. So first of all, we should all know the definition of maximum and minimum problem. Maximum and minimum problem is an algorithm that is calculated to find the maximum and minimum value in an array. Meaning here is that the maximum and minimum element can be found by comparing each element, which are numbers, and updating maximum and minimum values as and when only required. We should follow the question, what the question wants us to do. So a proper example of maximizing and minimizing problems in real life is that a store manager trying to maximize his profit or minimizes his losses by estimating prices for items to gain profit, and also how many to keep in stock to prevent losses when customers are not interested in that item. So the process of finding maximum or minimum value is called optimization. We are trying to do things like maximize the profit in a company or minimize the cost or find the least amount of material to make a particular object. Okay, so the first step to solve a maximum and minimum problem is to find the derivative of a function. For example, given y equals 2x squared plus 5x plus 2, for example. So we have to find the derivative of dy dx. Thus, the answer should be y equals 4x plus 5, as we times the square to the number 2, so we get 4x, and we remove the x from 5, and 2 we just remove the value as it is a constant. Second step is to set the derivative equals to 0 and solve the value for x. From this, we are able to gain the x value, which is the maximum and minimum points. Let's take the first example just now, which is y equals 4x plus 5. It will become 4x plus 5 equals to 0. We change the y equals to 0. Okay, and the value of x should be negative 5 over 4, as we change the direction and we get the value of x. So the last step is to insert the x value back into the original function, which was y equals 2x squared plus 5x plus 2, to find the y value. From that, this will give you the maximum and minimum points in the function. So now, let's take a look at a proper question. A rectangular fish pond with an area of 60 meters square is surrounded by a flower border with 3 meters wide on two sides, as shown in a figure below. Let x and y be the length and width of the fish pond respectively. Okay, so this question. The first question asks us to show the combined area of the fish pond and the flower border all together, using the given formula, which is a equals to 4x plus 360 over x plus 84. Okay, this is a fairly simple question, as we just have to use the values from the data given, which is the diagram shown, to find the dimensions. We should get the formula back to prove that the equation is correct to the area. So the second question asks us what dimensions of the fish pond will minimize the combined area. Okay, from this question, we all know that the first step we should do is finding the derivative of the original function, just like the last example that I given. So first step is to find the derivative from the function a equals to 4x plus 360x plus 84. And then, from the value of that, you should get the y value, which are the dimensions of the fish pond. Okay, and the last question wants us to find the minimum combined area of the fish pond and the flower border. From this question, it gives us a little hint, which is the minimum combined area. Then from that, we just have to substitute the y value from the question before into the original equation, which is a equals 4x plus 360 over x plus 84. to get the area of the fish pond and the flower border combined. So that is the problem. That is the identifying problem for this question, and I will pass this question to my teammates to show you the proper solving step to this question. Thank you.
Alright, so I'm Samuel Henry, and today I would like to present about the solution, which is part E. Alright, so let's solve a question here. So we have a rectangular fish pond with an area of 60 meters square is surrounded by a flower border with 3 meter wide on two sides as shown in the figure below. Let x and y be the length and width of the fish pond respectively. So this is the image. And we have three questions here. So this is the example question that I took from our practical book in calculus practical book. So the question is, show that the combined area fish pond and the flower border is A equals to 4x plus 360 over x plus 84. And second question is, what dimensions of the fish pond will minimize the combined area? And C, the final question is, what is the minimum combined area? And so I take the area for the first. So I take the area for the flower border. So I got 6 plus x in the bracket times with 4 plus y. So my final answer is 24 plus 6y plus 4x plus xy. And finally, we have 60 meters square for the fish pond area. The length and width is x and y. So I take x times y equals to 60 meters square. So I simplify I solve the equation. It becomes y equals to 60 over x. So I take the y value, and I insert it into my first equation, which is the equation of area of the flower border. So final answer is 4x plus 360 over x plus 84, and I wrote here proved. And for the B, what dimensions of the fish pond will minimize the combined area? So I take I differentiate. I differentiate. So differentiate becomes dA over dx equals to 4 minus 360 over x squared. So for the question, fish pond will minimize. My keyword here is minimize, which is after you differentiate, you must equal to 0. So I solve the equation, which is 4 minus 360 over x squared equals to 0. Then x squared equals to 90. So I get x equals to 9.489 meter. There is a negative value also, but I don't take the negative value because it is impossible for the length to be negative. And I take my answer, which is 9.489. I put it back into my equation, which is x times y equals to 60, the area of the fish pond. So 60 over 9.487 equals to 6.324 meter. And my final question is, what is the minimum combined area? Minimum combined area, so I take the value of my x and I insert into the equation of the 4x plus 360 over x plus 84, which is the combined area of fish pond and the flower border. So I just take the value of x and put it into the equation. So I get 159.895 meters square. So the unit is very important because there is a lot of unit that can be put into the answer that may change the value. So I hope this video helps, and for the next one is, and I think that's all from me. I would like to pass the conclusion and references to my friend Osman.
Okay, and now I'm going to make a conclusion and reference for our group project. So for the conclusion that we get from our group project is, the first, we must have a good understanding of differentiation. It may be difficult for us to solve maximum and minimum related question if we don't master the basic skills of differentiation. But if we master the basic skill of differentiation, we can solve maximum and minimum related question without a problem. And for the reference that we get for our group project is we get some of the references from internet and some from the textbook to solve the question reference to maximum and minimum related question. And that's all from me.